Hey guys, welcome to 9.1a, which is the first lesson of Unit 9, and we're going to be graphing exponential functions. So you have worked with exponential functions in the past, probably in Algebra 1. The first idea to remember, though, is that there's two types. We have exponential growth, and then we have exponential decay. So exponential growth is it's growing exponentially. That's where, when you have an exponential, it's where the variable is in the exponent. So let's say we had 5 to the x power, y equals 5 to the x. So x is in the exponent. And then you can have exponential decay, which is where it is getting smaller exponentially. And when you have growth and decay, they either change at a very rapid rate and slow down, or they change at a slow rate and then very rapidly. So the way to tell the difference between exponential growth and exponential decay is that the b value, which is your base, it has to be greater than 1. So if your b value is greater than 1, that means it's going to grow very quickly because the exponent is going to cause it to get really large. But if the b value is less than 1, then it's going to get smaller and smaller and smaller very drastically. You're going to notice some common parts here. Our a value is the vertical stretch or the shrink. We've seen that before with like parabolas. And then we also, once again, see h and k. This is going to be our starting point. All right. And then we also have asymptotes in these, and those are imaginary lines that the graphs do not cross. And we'll kind of talk about this. It's easier to see them once we start plotting some points. So the first thing that we're going to do, the shift is where we get our h and k. I probably should have specified that because these kind of graphs are going to go on forever and ever, left and right. So if you look at the original function, f of x equals 2 to the x, we don't see an h or a k. We're not adding or subtracting anything. So the shift is just going to be 0, 0. Is this growth or decay? Well, to decide if it's growth, we look at what's inside the parentheses, which in this case is the b value. That's 2, and 2 is greater than 1. So this is going to be growth. Okay, we'll get to the domain and range after. Now that we know it's growth and we know that the shift is 0, 0, we're going to do a table. Now for the x values, every single time we're going to use the same ones. We're going to do -2, -1, 0, 1, and 2. F of x, which is the same thing as y, is what's going to go in this column. Now this is where it's different. You have to think about each of these. So if I do off to the side here, f of -2, that's taking 2, and then this is my x value, but notice x is the exponent, so I'm taking 2 to the -2 power. Thinking about our knowledge that we learned in the last unit, this is the same as 1 over 2 squared, which is the same as 1/4. So that is what we get here. So f of -1 is 2 to the -1st power, which is just 1 over 2. So that's 1/2. Then we have f of 0, so we're plugging in 0 for x. Anything to the 0 power is just 1. This can be kind of tricky to remember. And then we have f of 1, which equals 2. And then f of 2 is where we plug in 2. 2 squared is 4. So every step we're actually multiplying by 2. And then this third column would be our a times y column, or a times f of x. Since our a value is just 1, we don't have to worry about this column for right now. Okay, so we're actually going to graph these. We're starting at 0, 0. So back 2, up 1/4. Then we're going to go back 1, up 1/2. Just do as close as you can. 0, 1, over 1, up 2. And then over 2, up 4. And as you can imagine, it's going to get really large really fast. So what we do, going to the right, is it's just going to go pretty much straight up to a certain extent. But going to the left, if you think about it, as we get smaller, like with the negative numbers, they're going to get closer and closer and closer and closer to 0, but they're never actually going to reach 0 because there's not an exponent that we have that would make it 0. This is where that asymptote comes in because it's the line that we're never going to touch, and that value is 0. So the asymptote is y equals 0. that's this line here, and we're actually going to draw a dotted line to represent that. So imagine this line is the one we're never going to cross. It's going to get really, really close, but never cross. Now the domain and the range. The domain, there's no restrictions here. We can plug in anything for x. So that's going to be all real numbers. So I'm going to do x as an element of the real numbers. But the range, however, we aren't going below a certain extent for our y value, and that y value is 0. And we're never actually going to get to 0 either. So what we're going to say is y is greater than 0, not greater than or equal to, because it's never actually going to touch 0. Okay, and we've got it graphed. So let's go ahead and try this next one. Y equals -2, 2 to the x power. So again, same values, -2, -1, 0, 1, 2. Our shift is still 0, 0, because we're not adding or subtracting anything to x. The growth or decay, this one's going to be growth because 2 is still, bigger than 1. So I'm just going to circle growth here. Okay, the next thing we're going to do, now since we have the same f of x column, this is going to be the same as like -2, or not -2, 2 to the -2, which is 1/4, 2 to the -1, which is 1/2. We're going to get the same values here. It's our a column that's going to change, that third column. So we got 1/4, 1/2, 1, 2, 4, the same values that we got up here. This column, however, a times y, notice the a value is -2. So we need to take everything in that middle column times a, so we're going to get -1/2. 1/4 times -2 is -1/2. And we get -1. -2 times 1 is -2, -4, -8. So these values are going to be a little bit bigger. And then we cross off that middle column. So now we're going to start out by graphing from 0, 0. -2, -1/2 goes down. Then we have -1, -1, 0, -2, 1, -4, and then 2, -8 way down here. Now this one, it's getting exponentially smaller. And that's kind of the idea here, is that our y value is drastically decreasing. But the x value is also getting larger. But as we go left and right here too, we still are never going to get to 0. It's the same idea, because there's not an x value that would make the whole thing 0. So we draw our asymptote, that dotted line, and it's going to be the same as the last one. It's going to be y equals 0. Now the domain, just like last time as well, all real numbers, there's no restrictions. And the range is going to be, trying to do this in more proper format. X is an element of the real numbers. This time though, y is below that line of y equals 0, so y is less than 0, not equal to. All right, so now we kind of see that. Now we're going to see one that's a little different, and we're going to have a different shift. So this time the table, we're still using the same values, -2, -1, 0, 1, 2. The shift though is we have this +2, so that means we are going from, it's not with the x, so it's 0, 2. We're going up 2 as our new starting point, if you want to think of it like that. This is actually going to be decay as well, so we're getting two new things here. The reason is because 1/2 is less than 1, so that's how we know it's decay. All right, so the shift of 0, 2, we also need to fill out our f of x column, which is going to be different because our base is different. So now what we're doing is 1/2 to the -2 power. Here's an interesting trick though. Remember that we can do this reciprocal first. So 1/2 becomes 2/1, and then it becomes +2. So we end up getting 4. And then if we do the same thing with 1/2 to the -1, we end up getting 2. 1/2 to the 0, 1. 1/2 to the first is just 1/2. And then 1/2 squared is 1/4. So what ends up happening is we just get the inverted values of what we had above. So now we're starting with 1/4, or we're starting with 4 and going down, whereas here we started with 1/4 and then went up. And our A value is just 1, so we're not going to have that third column to worry about. Now, the trick to this one, our shift is we are starting up 2. So what you can do, thinking about the fact that we had to move up 2, that's going to move our asymptote to be right here. Because it shifted it up from y equals 0, and now it's going to be y equals 2. Brought the whole thing up. And now we're going to graph these points from this point, our shift point, you can think of it like. So we're going to go back 2, up 1, 2, 3, 4, right there. Back 1, up 2, 0, 1, 1, 1/2, and 2, 1/4. And it's just going to get closer and closer and closer to that line. Now notice though, the difference between exponential growth and exponential decay, as we come from the left side, our values get smaller as x grows bigger. But as we come from the right side, or like exponential growth, when you come from the left side, the x values get bigger, then our y values also increase at a more drastic rate. So it's kind of like they're inverted. Now the domain, still all real numbers, and the range, since we're above the line y equals 2, everything has to be greater than 2, not equal to it. All right, I'm going to do one more because this video is getting kind of long. So let's do this one here, example 6. Excuse me. So we pick the same values, -2, -1, 0, 1, 2. Now what we can do is note our shift is +1 and then -3. It's the opposite when it's x plus 1, because if we go back up here, it's x minus h. So just like usual, h is the opposite. That's going to make this a -1, -3 shift. So that's going to move it to the left one. So we're going to do a dotted line here. We're going to make this our new axis. And then we're going to do a dotted line at -3 for the y value. That means this is our new center point where those lines intersect. Is this growth or decay? It's going to be decay because the b value is 1/3. All right. And then the asymptote is going to be y equals -3. It's always the k value. In this case, if you probably noticed that earlier, but now the f of x. So we're working with 1/3. So we have 1/3 to the -2 power to start. Remember, we just flipped that, so it's going to be 3/1, and then it's going to be squared, which gives us 9. So the pattern for this is you either multiply by your reciprocal or you divide. In this case, if we divide every level by 3, so we would have 9, 3, 1, 1/3, 1/9. They're just going to be inverted for each other depending on if it's growth or decay. Okay, and we do have an a value that we have to be careful of. A is -2. So that means we have a times y. So we're going to get -18, -6, -2, -2/3, and -2/9. Now we don't care about this column anymore, so we're going to graph it. So we're going to go back to up 18 is going to go off the grid. Oop, actually, it's negative though. It's back to down 18 would go off the grid. Back one down 1, 2, 3, 4, 5, 6. 0, -2 is going to be on this line here. 1, -2/3 about right there, and then 2, -2/9, getting closer and closer to that line, but we never actually touch. And just show that you're not going to cross that. Domain, all real numbers. And then the range is we're smaller than our y value, so y is less than negative 3. Okay, so go ahead, give these a try, and then do the exit